Hello, everyone. Welcome to our fourth and final night of the Virtual Nature Summit webinar series. Today, we have a very special guest, Dr. Drew Andrews. He's a geologist and section head of the Geological Mapping Department at Kentucky Geological Survey, which is a program through the University of Kentucky. He is going to give a presentation today about geological landforms and regions in Kentucky. But before we jump into that, I'm going to give you a brief overview of who we are as an agency and what we do. Backtrack a little bit. My name is Maddie Heredia. I'm a land manager and outreach specialist for the Office of Kentucky Nature Preserves. And I've got a few slides. If you hang tight with me for 1 second, that I'm going to share about our agency. Drew, can you just give a shout out if you can see my screen?
Yep, you're good.
Awesome. So we are the Office of Kentucky Nature Preserves. We are a state government agency in the Energy and Environment Cabinet. Here's a list of our duties by statutes. I'm not going to read this entire thing, but for the gist of it, our agency acquires land to protect it and conserve it. Based on a few things that make it valuable to us, we protect land, or we buy land that has rare and endangered species on it. It's got unique habitat that there's very little left of in Kentucky. It's a unique recreation opportunity for the general public. We also document and have a database of all the rare and endangered species that we track and monitor in Kentucky. And so with all of that property, here's a map of it across the state. We have several properties that we own and manage ourselves, but we have a lot of involvement with other properties that you might be familiar with, like state parks, WMAs, Division of Forestry, even some federal lands that we hold easements on many conservation programs. And so in total, we have about 130,000 acres of property that we have involvement in for conservation across the state. And my job is to visit all of those properties once a year. So it's not traveling for me. So in our agency, we have a few branches. Our natural areas branch is tasked with land management and trying to manipulate habitat to create the best environment for some of our rare and endangered species left in the state. Our biological assessment branch, their job is to go out onto newly acquired properties as well as update records from existing properties on what is there, what's unique about it, what's special, what kind of rare and endangered species are there. And we do a lot of environmental education and outdoor recreation. A lot of that has come to halt due to COVID-19 in recent years, but thank goodness for technology, and we've been able to still provide some great resources virtually. With all of that data that we collect that I mentioned before, it is made readily available for the public through our Kentucky Biological Assessment Tool, which can be found on our website. And lastly, the reason that we are here today, some of you may already be familiar with this, but in 2019, we started planning an in-person Kentucky Nature Summit event at Pine Mountain State Park. It was going to be a 3-day event full of multiple field trips led by expert biologists from multiple different agencies. It was going to be a really cool event covering things like herpetology, birding experiences, wildflower hikes, fire and forest management, water quality events, and so much more. We've had to cancel that 2 times now because of COVID and gathering restrictions and stuff like that. But we didn't want to leave everyone hanging, and so we wanted to provide this mini virtual webinar series to kind of make up for that and cover some of the topics of things that we're going to explore at this in-person event. And maybe one day we will be able to host this in-person event. Fingers crossed. So with that, I'm going to turn it over to Dr. Drew Andrews now. And you should have sharing abilities now.
Okay. You probably see my screen. Let me switch to PowerPoint. There we go.
Oh, and I will say before he begins, you should all have a questions chat box in your view. I highly encourage you to ask questions throughout the entire presentation. You do not have to wait to the end. I will ask the questions, I will moderate them and ask them at the end. But please, if something comes up on the screen that you're interested or curious about, go ahead and ask that question right away. And that's all.
Absolutely. So Maddie, do you see my stone wall picture? Is everything working okay?
Yes, we've got your presentation on the screen ready to go.
Okay. So let's go ahead and begin. I want to say thank you for everyone who is attending or who watches this later on the recording. I always enjoy sharing my appreciation and my enthusiasm for the geology of Kentucky and for the many impacts that it has, but especially in our landscapes. I do work at the Kentucky Geological Survey, and for some folks that might be an entity that you're not entirely familiar with. So I just wanted to give a little bit of background on our organization. We actually predate the University of Kentucky. The Kentucky Geological Survey was founded back in 1854. We are only on our 13th director since that time. We've had a lot of stability. We are a non-teaching department at UK. We're a research and public service organization, so we're not regulatory. The original KGS was a part of state government, but moved over to the university after World War II. We now have a full-time staff of approximately 45 people. We're divided across several sections, focused on energy and minerals, hazards, water, mapping, and then we have folks that focus on information management, and then our administrative section. We actually have 3 locations. I am currently sitting in our main office on the UK campus in Lexington. We also have what we call the Earth Analysis Research Library, affectionately known as EARL, where we have the state's largest rock collection. We have a very large warehouse full of thousands of geologic rock cores and cuttings and other geologic samples that have been collected from across the state. And then in Western Kentucky, in Henderson, we have an office that is focused on water research. And why does my organization exist? My department collects a lot of different information. We study the geology, and it's because of the impact, it's because of the applications, it's because of the need for understanding of energy resources, of environmental management, for transportation, for geotechnical and engineering considerations, and for various geologic hazards such as flooding, landslides, or earthquakes. And this organization has existed for a very long time. This is an image from 1875 of some of the geologic mappers that were working at the Kentucky Geological Survey. And since that time, the technology has changed, but the fundamental purpose of what we do has not. Our job is to go out and collect geologic information, to research that, to interpret it, to understand it, to analyze the data that we collect, and then to make what we learn available for the use and benefit of the state of Kentucky. So geologists always show pictures of people outside, and that is a fundamental part of what we do, is getting outside to look at the rocks, to understand what we're standing on. But a lot of our work also happens in the lab, where people are collecting information, examining the samples, running things through the lab, collecting new data in various different ways. And then an often underappreciated aspect of what we do is the digital data management. And so collecting all of that data into databases, assembling it together, and then communicating it, hopefully in some useful way on our website, is all a critical component of what the Kentucky Geological Survey works on, and something that we work on every day. My particular job is working with geologic maps. Kentucky is unusual in that we have geologic maps like this available across the entire state. So anywhere you go in the state of Kentucky, we have a 1 to 24,000 scale detailed geologic map that tells you about the different rocks that outcrop at the surface in that area. No other state larger than, I believe, Connecticut has that information available. Not only do we have these published paper geologic maps like what you see here, but in Kentucky, we have digitized all of those maps into a digital mapping database, and we provide that information for free through our website. And we'll talk a little bit more about the website later, but I'm particularly proud of the work that the Geological Survey as a whole has done over the last 30 years, 3 decades of digitized, 40 years, 4 decades, digitizing this information, water, coal, geologic maps, oil and gas, earthquakes, and landslides, providing all of this information for you. And so it's something that we're a little proud of. It's the fact that we do have this robust data source, including this complete set of detailed geologic maps that are available for the use of our entire state. Now, this map, these two maps look very similar. This is a detailed geologic map that shows the different rock layers that are at the surface across the entire state. And this is mosaicked together from those detailed geologic maps that I mentioned that are statewide. This map is a general cartoon showing the landform regions, or the physiography, across the different parts of the state. And this is a diagram that a lot of you are probably more familiar with. People have heard of the bluegrass region. People have heard of the knobs. People know where the Eastern Kentucky coal field and the Mississippi embayment or the Jackson Purchase are. And so for part of this talk, I'm going to talk about how we understand these landform regions and a little bit of the geology underneath them. I could literally talk for hours about this, and I have done that to people before, but I respect you all, and I am not going to do that to you tonight. And so I'm only going to touch on some high points. And then if you have more interest, if you want more information, by all means, contact us, talk to me, and we'll try to get you the information and the resources that you need to pursue what you are interested in. And so you will run across this term a lot of the times, physiography, or a physiographic map of Kentucky. And that term is a contraction of physical geography. That's a description and an interpretation of the landforms, and especially on a larger scale, not just on a specific hill slope scale. And so I tend to prefer to use the terminology landform regions just because that makes a little more sense to people. And this is different from the study of geomorphology. Geomorphology gets into the specific study of the actual landforms themselves and is more process oriented. How did this hill slope form? How did this river valley develop? What is the likelihood of rock failure from this slope? Now, the Kentucky Geological Survey has dealt with the idea of physiography or landform regions for a long time. And there's a whole series of publications that were created in the 1920s that address these for different parts of the state. And then there have been some other summaries that were later produced. And then there's some much larger multi-state or national regional syntheses that have included, of course, parts of Kentucky into these larger contexts. But each of these did not necessarily provide, in our modern world, a geospatially referenced framework for people to work from. They're from these kind of general cartoons or a very general national illustration. And so as part of an effort to provide a GIS layer that people could use for analysis in digital mapping software, we've come up with a different set, well, same set, but a more precise delineation of these landform regions in the state. And the basic terms we're going to be using are provinces and sections. The provinces are the really big picture things that are going to extend across states. The sections are a little more localized, and they're some of the more familiar terms that we recognize here in Kentucky. And so 3 provinces cut across Kentucky. The Coastal Plain Province, which involves a lot of the lowlands in the lower Mississippi River Valley. The Appalachian Plateaus Province, which is essentially part of Greater Appalachia. And then the Interior Low Plateaus Province, which is the sort of normal rolling topography of varying structures and landscapes that we see in between across the rest of the state. And so the Jackson Purchase is part of that Gulf Coastal Plain. And then what I call the Cumberland Plateau and the Cumberland Mountains. The names aren't critically important, but those are just a way to subdivide, represent Eastern Kentucky, the Appalachian Plateaus. And then the Bluegrass, the Highland Rim, and the Shawnee Hills are the primary sections that we have in the interior low plateaus. And you can see that there are some additional subdivisions inside each of these sections. And these were delineated based on the pattern of landforms, the landscape pattern in each of these different areas. And so the idea is to outline areas that have essentially similar hills or a similar lack of hills, as the case may be in different places. And so some of the data sets that we used, Kentucky now has statewide LIDAR, which is much, much more detailed than the data sets used to illustrate here, but they do provide a fantastic data set for examining landscapes. And other people in my office are doing some amazing work developing applications and using that high resolution LIDAR data to better understand the landscape of Kentucky. And so if you are interested in those quantitative or high resolution landscape studies, by all means, reach out. My contact information will be at the end of the presentation. I'd love to talk to you about that. But from that landform data, that digital elevation data that's available, we can calculate slopes. In this particular image, the warm colors, the reds and oranges, represent steeper areas, and the blues and greens represent less steep or flatter areas. We can use something called relief, which would be just a measurement of the difference between the bottom and the top of the hills in a particular area. And again, the warmer areas, the reds and oranges and yellows, represent higher topography, where there's a bigger difference between the creek at the bottom and the ridge top at the top. And then the lower topography, the lower hills, would be represented by the cooler colors here. And then the geology. Each different color on a geologic map represents an age and a general type of rocks. And so all of these pieces of information are used to put together a map that outlines the different landforms. And so if you drive through Eastern Kentucky, for instance, if you're driving near London, Kentucky, things are going to look very differently than if you are in the gorge at Red River, near Natural Bridge at Red River Gorge. And they're going to look yet again very different than if you're driving through Pike County. And so rocks underneath are why we end up with these different landscapes. And so when we're in Eastern Kentucky, the primary rocks that we find are shale, sandstone, coal. And then there's an intermediate between shale and sandstone called siltstone. It's just very fine grains of silt, or very, very fine sand, if you will. And those are most of the rocks. And these rocks represent material that was eroded off of the last stage of the Appalachian Mountains. The Appalachians have been pushed up into the air and eroded away, and pushed up again and eroded away, and then pushed up yet again a third time and eroded away again. And this last time that the Appalachians were eroded away, a lot of that material accumulated in a giant tropical coastal plain that is now preserved as the rocks we find in eastern Kentucky. And so we find old river deposits and old bay fills, and we also find old swamps that are represented by what we now see as coal beds. And so that has the shales affect the landscape that we see, in that it erodes very easily and can make the steep slopes. The sandstones can make even steeper cliffs. And then the coal beds themselves attract mining, which has led to some human influence on the landscape and landform, as we do surface mining versus underground mining versus mountaintop removal. Now, these sandstones in eastern Kentucky can lead to some fantastic landform features in the natural arches. And Steve Martin in my office is involved with a project to inventory these natural sandstone arches across Kentucky and compare that inventory to what is known from other states. The process is still, the inventory is still in progress, but we believe that Kentucky may have the largest number of these sandstone arches other than the state of Utah, which has Arches National Park. So we might be second. And so if you go to Natural Bridge, if you go to Carter Caves, if you go several other parks across the state, you're going to encounter these beautiful sandstone arches. And there's an entire story that could be told about how these form, the different ways these form, and what they represent in the landscape. But as we go across eastern Kentucky, you'll in some cases see these gigantic road cuts. And ironically, these are actually a really important source of undergraduate and graduate student education and professional education for geologists. Kentucky has some very unique, some very accessible, and some very informative road cuts. And so a lot of people travel from all over the world to come and look at these big road cuts in eastern Kentucky to understand how that giant coastal plain evolved and developed, because in other parts of the world, they are built on a similarly aged coastal plain, but they can't see it as well as they can see it in eastern Kentucky. So they come here to learn and then go back to their areas to then look for coal, look for oil, to understand the geotechnical foundation of what they're working on. And so Kentucky is actually a very important geological laboratory because of its rocks. But these rocks, these sandstones, shales, and the coal, leads to a landscape where a lot of our hills are very steep, the ridgetops are very narrow, and so a lot of the places that are available for people to build their homes, build their communities, to focus our transportation is down in the river bottoms. And that's fine, but then that makes that infrastructure in those communities vulnerable to both flooding and also to landslides. And so this is looking across a wide river valley near Moorhead, and the outcrop of rocks that you see here in the distance is actually the head of a large landslide that's sliding down this hill. Fortunately, there's nobody that has built below this specific landslide, but it is just a good illustration of some of the hazards that the people in eastern Kentucky have to face because of the restrictions imposed by their landscape. Now, when we get into central Kentucky, we have the bluegrass region. We're familiar with the inner bluegrass, where the horse farms can be found. We have the Palisades along the Kentucky River, and then around the outside of the bluegrass region in a big horseshoe is the bluegrass hills and the outer bluegrass. And this area is home to some of the largest urban development in Kentucky because there's relatively flat ground available, but also a lot of farming. occurs here. And the predominant rock through this region is limestone. These thin-bedded limestones occur in varying proportions all across the bluegrass. In some cases, there's a little more shale. In some cases, there's a little less shale. But for the most part, it's limestone or limestone and shale in the bluegrass. And that's what is really a big driver for what we see in central Kentucky. And so the horse farms are stereotypical, gently rolling area, very fertile soil, really good for thoroughbred horses, but also very good for cattle and for raising row crops, whether it be corn, tobacco, hemp is making a resurgence. It has the limestone has a very profound effect. And of course, locally, the Kentucky River has cut down into these limestones, giving us the cliffs of the Palisades. And then also you have a lot of sinkholes and caves that occur in the bluegrass region. Caves in the bluegrass region are not as well known as what we find, however, in the western pennyroyal, which has also limestone. But the limestones there are a little bit different. The limestones in down around Somerset and also down around Bowling Green and Munfordville, the layers of limestone are thicker and there is much less shale involved. And so these areas have developed much larger and much more significant cave systems than what we see in the bluegrass. And so the Corvette Museum, Mammoth Cave, Diamond Caverns, all of these features, Lost River Cave, all of these features are generated in this different type of limestone that we have in the pennyroyal region. And as I mentioned, sinkholes are a significant thing. And so this is a broad sinkhole in some of that is called, it's part of what's called the sinkhole plain. This is in, I believe, Meade County, Kentucky, but there are just sinkhole after sinkhole across a very flat area. And the one thing that you don't see here are surface streams. There isn't a creek in this view because the rainwater soaks underground instead of flowing across the surface and in a stream. And so that has profound effects on the landscape and also has profound effects on the soil. When you get on the sinkhole plains around Elizabethtown and around Bowling Green and down toward Hopkinsville, you have these thick red soils it can be very clay rich. That has implications for agriculture, has implications for water drainage, also has implications for radon. Radon is an often overlooked geologic hazard in Kentucky. And some of these areas with the karst areas that have these prominent red soils are some of the highest radon producing areas in the state. And that's something yet another group in my office is studying. So something we're very interested in. Now this meeting was supposed to happen ideally at Pine Mountain, and hopefully it will again. And so I just wanted to throw in as a landscape feature a little bit about the geology of Pine Mountain. Pine Mountain is basically a refugee. Part of it came from Virginia, part of it came from Tennessee, and it was during the very last stage of construction of the Appalachian Mountains that I mentioned before, as the continent of Africa was colliding with North America to create the supercontinent Pangaea. Some of the rocks got shoved in our general direction. So here's a very general chat talking about some of the different areas. So Cumberland Plateau, Pine Mountain Thresh Heap, and then beyond in Southern Virginia and Eastern Tennessee is a series of long linear ridges that we call the Valley and Ridge Province. Now, part of the rocks that were in the position of the Valley and Ridge Province essentially got bumped as the continents were colliding and shoved from the side, and then that caused that sheet to be shoved northwestward into what's now Kentucky. And it actually leads to the rocks being shoved over the other rocks. And it is known as what is known as a thrust sheet. And so geologists are very fascinated by rocks that aren't where they used to be. And so this is something that we really enjoy working with. So I'm hoping that in the future we can get back to Pine Mountain and we can show some of these features down there in person. But Cumberland Gap, Pine Mountain, Pound Gap, Kingdom Come State Park, there's a whole series of things that are down near or along Pine Mountain that are definitely worth seeing and worth exploring. Now, if you are interested in understanding more about geologic maps, I would recommend for you this publication we produced several years ago called Geologic Maps and Geologic Issues in Kentucky, a Citizen's Guide. A digital version of this is available for free on the KGS website. We also have printed copies if you prefer them. They're a very handy dandy glossy little pub for folks to just kind of get the basic idea of what geologic maps represent and what they can tell. Some other basic sorts of resources we have available are a publication called Rocks and Minerals of Kentucky. And then a professor at the University of Cincinnati worked with my office to develop the geology of the Cincinnati, Northern Kentucky region. His name is Dr. Paul Potter. He recently passed away. But he was a very good friend of the Kentucky Geological Survey and of Kentucky geology in general. And this publication, if you're in the Northern Kentucky region, is a wonderful resource for understanding the geology and also the applications and the implications of the geology for that region. For another example of something available through our office is this karst occurrence in Kentucky, which is just what it says. Where are you likely to find karst features in the state? Caves, sinkholes, springs, those sorts of features on the limestone areas of the state. And more specifically, anywhere you are working in the state. I did mention that there is a geologic map available. And those geologic maps, however, are going to be written in the language specifically for geologists. They're going to be a technical scientific document that it's easiest for a trained geologist to understand. And that's not to say you couldn't or shouldn't try, but there are going to be things on there that may not be exactly clear for you. And so one of our geologists several years ago started a series of maps. They're called Generalized Geologic Map for Land Use Planning. And there was one of these produced for every county in Kentucky. And so these show a geologic map, such as this one for Morgan County, and then some photographs discussing different features or processes or hazards that are important for that county. And then there is this table of general guidance for planning whatever you some very basic things across that area, which might be septic systems, building foundations, roads, parks, basic things such as that. Now, if you have a specific interest that perhaps isn't addressed by this guidance, I would absolutely encourage you to contact me because that is in my group in the geologic mapping section. One of the things that we want to do is we want to make this geologic information and these geologic maps accessible and useful to the widest possible audience. And so if you are interested in plants, if you are interested in minerals, whatever the case may be, talk to us. Maybe we might be able to find a way to translate, to develop a new product, something that will help you in the work that you do, apply geology to what you do. With nature preserves, one of the things specifically that I can point to with some pride is the ecoregions map of Kentucky, which hopefully looks vaguely similar to the landform regions map that I started the presentation with, because it is basically the same thing. That landform regions map was used by the co-authors of the ecoregions map to start their conversation. And each one of the polygons on this map was generated with information on geology, soils, and landforms, but also looking at plants, invertebrates, etc. So the fauna and the flora that are endemic to certain parts of the state. And so there is a whole poster that is available. If you need a copy, I actually have a box of them here, but there's a digital version that's easy to get to. But in your work, if you're interested in natural areas, etc., that can be a wonderful resource for putting things in context. And so I took this screen capture today, and usually this is much more colorful, but there was a glitch with Facebook today, and somehow the news article mentions my name, which is strictly a coincidence, I assure you. But the main thing is the web address. You go to www.uky.edu/KGS. This will bring you to this website. And from here, you can get information about Kentucky geology. You can find out information about our research. You can access our geologic data. You can explore our publications and our online maps. And we have some specific information in the website about science education, about science education standards, and how some of our resources can be used to help teachers and students work with those different standards. And so the two things I'd really like you to take away tonight is that the Kentucky landscape is directly attributable to the underlying geology. And it's something I would love to explore with you more. And my office, the Kentucky Geological Survey, has decades of resources available to help you explore the geology and understand the geology across our Commonwealth, whether you do technical work and research and preservation work, or whether you're just wanting to enjoy the landscape and walk around and see what you can learn. We definitely have some materials that can help. And so with that, I will put this contact information. I wish that were me. The gentleman in the picture is actually someone named Willard Rouse Gilson. Dr. Gilson was the 6th state geologist of Kentucky back in the 1920s and 30s. And other than having fabulous boots, Dr. Gilson was one of the most prolific authors on Kentucky geology ever. And the rumor is that Dr. Gilson wanted to have the most entries in the Library of Congress under his own name of anybody else. And so he set up a self-publishing exercise, actually had a printing press in his basement, and he would print out prolifically reports and pamphlets on the geology and on the history of Kentucky. And so very often, if you are interested in the geology of Kentucky, you will end up coming across his name. However, Dr. Gilson is no longer available, but my office is. Kentucky Geological Survey. Again, my name is William Andrews. Everybody calls me Drew. My email is there. Also, our web address, kgs.uky.edu, is the shortcut to get to us. And with that, that is what I had to share. And I see the chat is blinking. I'm looking to see if there's anything. My email address.
I dropped your email in there it was easier for people to copy and paste if they wanted to.
Wonderful. And so that is what I had to share. So I thank you all, and I'm game for questions.
Thank you so much. That was a wonderful presentation. And to everyone here, I was telling Dr. Andrews that this was one of the most popular presentations that registered for in this Nature Summit series. So thank you so much. And we do have a few questions here. The first one is, can you further explain how historic swamps become coal beds?
Yes. The modern analog is currently occurring in Indonesia, just for reference. The Swamps are places where plants grow prolifically, and because of how the plants are able to grow, they prevent additional sediment from washing in. So the plants kind of overgrow where the sediment is coming down rivers or other sources of sediment, and it sort of blocks sediment out. So you end up with just leaves and stems and roots and more leaves and more stems and more roots, just building up and building up and building up because of the high biologic productivity in the swamp. And then something happens. The landscape gets pushed down because of the tectonics, because of the mountain building pushing up a different direction, and sediment finally overtops and buries that swamp. And so you go from having the peat, the natural plant material accumulating, gets buried and sealed underneath other sediments, and then progressively gets buried deeper, it's buried deeper, it's buried deeper. The farther down you bury something, it instantaneously feels pressure. So you're squeezing water out, you're squeezing out the empty space, you're smashing down any pores, any organic pores in like wood or whatever are getting mashed. And then eventually there's more heat that accumulates as you're getting deeper, and essentially you cook it. And so you go from peat to coal to eventually anthracite to just graphite. If you keep cooking the organic material underground, it progressively changes. And so there's just it's a burial process. So the peat grows because of high biologic productivity, or is able to accumulate because of the high biologic productivity. Once that does get buried, progressively gets deeper buried, more pressure, more heat, eventually becomes coal.
Awesome. Is there a change between physiographic section slash, is the change between physiographic section slash provinces more gradual? How are these hard lines slash shape files determined for some GIS layers?
That is, if you back up enough, looking at these GIS data, the boundaries are nice and sharp. Oh, there's clearly a change there. Once you get down, especially into the actual landscape, for somebody that's doing rare plant work, you're going to be right down in the landscape. And where do you draw the line? Even between, where is the bottom of a hill? I mean, pick a hill and try to agree on where the bottom of a hill is with somebody standing next to you. That's an excellent question. Those boundaries are intended to be used at a general scale, in a very general map. If you try to zoom in on those, it's going to be problematic. Some of these boundaries are a transition that's a half a kilometer wide, a few hundred meters wide. And some of these are across a couple of kilometers. And so it's landform regions are big boundaries by nature. But the GIS people need a polygon. And so they were drawn outlining patterns of slope, patterns of relief. And one of the projects that we have the capability of here in the office, and we have talked about doing, but we haven't actually executed yet, is taking this new LiDAR data that is completely independent from how these regions were outlined. And my office's expertise, growing expertise, and it doesn't sit in this chair, but down the hall, in quantitatively analyzing that LiDAR data. And so let somebody use machine learning to test these regions on a LiDAR scale, which is crazy detailed compared to what I was using. How do these hold up? And so that's one of the things that I'm hoping we can do over the next year or two is to run that analysis and see if independently, quantitatively, that LiDAR data supports or suggests significant revision to those lines. So we'll see.
That's super fascinating to kind of test the accuracy of these historic things that we've been using for years.
To see whether the laser says that the human operator pulled it off okay or not. So everything I did was pre-LiDAR, and I literally just hand drew things based on patterns I could see. And then I would drive out and kind of, do the hills seem to change in this area? Okay, yes, no. And so it was just kind of a series of little day trips driving out and back and then playing in the computer. The LiDAR, somebody analyzing the LiDAR could probably do it overnight once they get the algorithm set up. And so it'll be interesting to see what the computer thinks I did or not, you know.
That's amazing. That's fascinating. And just for we probably have different levels of knowledge of mapping and stuff here, but I just want to clarify that for that question, for those who don't know, GIS is Global Information Systems, and it's just it's a computer program for mapping, essentially.
It is a combination of digital mapping and databases. And
yes.
so in any graphics software, you can draw lines and make a map, theoretically. But the power of GIS is being able to connect data to the lines, to the points, and to the areas, and then you can do analysis. And so geographic information system is digital mapping with a database that you can build in. And so it's
absolutely
extremely powerful.
Are all caves in Kentucky limestone, and can you go into further detail on how they form?
Most caves in Kentucky are limestone. There are going to be some features, like there are rock shelters in sandstone. Those are very common. How deep does the shelter have to get to be a cave? My father used to do cave inventory. I think he said 50 feet, but I don't know. I do not know the formal definition of what qualifies as a cave versus not. But for the most part, caves in Kentucky are in limestone. As to how they form, Kentucky's in a humid climate. Rain falls, it soaks into the ground, it soaks through the soil, and it hits the top of rock. And if it gets an opportunity to go down into a fracture in the rock, it will trickle in through that fracture. If you're dealing with rocks like sandstone, the water just goes down through the fracture until it hits another fracture, et cetera, until it flows out somewhere. When you're dealing with limestone, chemistry starts to become important because rainwater is naturally a little bit acidic. People have heard the term acid rain, which means that chemicals in the atmosphere have made the rain even more acidic. But rainwater just on its own, naturally, is acidic. And then when it trickles through a lot of Kentucky soils, it becomes even more so. Because of the chemistry of the soils, the mineralogy of the soils, it reacts. And so it becomes an acid that wouldn't burn your skin, but it's a reactive, weak acid. And when that comes in contact with limestone, limestone is calcium carbonate. And the bond that holds calcium to the carbonate is weak enough that the acid can, that weak acid can pull it apart. And so as water goes through the fracture on a sandstone, it just goes through the fracture and trickles through the grains. As it goes through a fracture in a limestone, it can actually dissolve away some of the wall of that fracture. And once it starts to succeed and that fracture gets a little wider, then it's easier for water to go through that space. And so more water goes through wherever the dissolution occurred, which helps more dissolution happen, and then more dissolution happen. And so it then becomes a reinforcing thing, and it eventually opens up big enough that it becomes something somebody can look into or go into and becomes a cave.
Awesome. We have two more. What is your favorite geological area or feature in Kentucky?
Wow. That's a hard one to answer. My father used to own some property near Natural Bridge, Kentucky, that had enslaved near Red River Gorge that had a couple of natural arches on it. That was pretty. So that landscape in Red River Gorge is I have an emotional connection to, family history connection to. I grew up on the edge of the bluegrass in something that was used to be called the Eden Shale Belt, that I call the Bluegrass Hills. It's just clay, limestone hills with cow pastures and tobacco, and it's not geologically dramatic, but it's important to me, right? And then I live here in Lexington. I appreciate the McConnell Springs and the horse park and the horse farms and the landscapes there. And then I have family that live in Owensboro, which is Ohio River floodplain. And then there's some Ice Age lake deposits from when the glaciers were nearby up in Ohio and Indiana during the Ice Age. A lot of that sediment was flushing down the Ohio River, and it clogged up all of the creeks and rivers that drain to the Ohio. And so lakes formed in the Kentucky River Valley and the Salt River Valley and the Green River Valley. And so you get these big lake deposits. And my grandmother lives on one of those. And so that's just kind of a neat story that 20,000 years ago, there was this glacier that was just belching sediment down the Ohio River, blocked up all our rivers. And my grandmother lives on the mud flat that used to be part of the Green River, So I don't know. It's just I really enjoy Kentucky, and I enjoy the geologic stories behind the different landscapes in Kentucky. So that's it's just going to always be a long answer for me. So
all of them. Or you appreciate the geological diversity.
yes,
I also live in Lexington. I also live in Lexington. I really appreciate the proximity of the Palisades.
Yep.
Exploring those. And then lastly, this isn't really a question, it's a comment. It may be someone from your department, I'm not sure, but when that question was asked about how coal forms, they copy and pasted a link from your website, and we'll go ahead and add that to the chat so that people can click on that if they would like to. And if you have any, I know you had some resources and stuff on your slide, but if you want to, Dr. Andrews, you can email them to me, and then I will distribute them as links to the mailing list of who signed up for this, if anyone's interested.
Can do that, definitely.
Awesome. Well, if that was all the questions, let me check one more time. I think that was it. Thank you again so much for this presentation. This is a topic that we are not experts in. We don't cover a lot, so we really appreciate your input and all the resources that you provided today, and just taking the time to present to us. So thanks again.
Absolutely, it's a pleasure, and I look forward to talking to this group again sometime, I hope, and hopefully in person. One day. So
one day. Well, all right, that concludes. Yeah.
You see more than just your eyes, right? So yeah. One of these.
Well, that concludes our fourth and final webinar. Thank you so much all for joining. Some of you have been here with us every night. These have all been recorded, so if you missed some throughout the week or you weren't able to watch the full webinar series or session, we will put them on our YouTube page. The best way to be informed about when those are up is to subscribe to our YouTube channel at Office of Kentucky Nature Reserves, and you will get a notification every time there's a new video. And I will share that with you as well, Drew. So again, thanks everyone, and till next time, maybe in person.
Thank you.
See y'all.